1033, Chapter 4, Section 1, System of Equations, Part 2. So this is the second video for Chapter 4, Section 1. First thing we go over is the substitution method. All right, now, remember it's a system of two equations, and anytime I notice that I have a variable by itself, then in this particular example, the variable is on one side by itself. Well, let's say the 2y was over here, then I would subtract or add the 2y over and get the variable by itself. What that means now is that x is equal to this 2y minus 5. So I can take this 2y minus 5 and substitute it in for x in the other equation. Substitution. Once I substitute it in there, now I've got to distribute the 2. I get 4y minus 10 plus 4y equals negative 6. Collect like terms. I get 8y minus 10 equals negative 6. Two-step algebra problem. Add the 10, divide by the 8, reduce my fraction, and I get 1/2. So y is 1/2. Remember, a system of two equations is always going to give me an ordered pair. So now I can take this 1/2 and substitute it into either of the original equations. All right, either one of the original equations. And so what happens here is I'm putting it into the first one. So I put 1/2 here, I get 2. So now I have 2x plus 2 equals negative 6. Subtract the 2 over, divide by 2, I get negative 4. So I get the ordered pair solution of negative 4, comma 1/2. Would have been just as easy to take that 1/2 and plug it into here. 2 times 1/2 is 1, 1 minus 5 is negative 4. So I get x is negative 4 as well. Second way of solving a problem is by elimination. I chose this problem because it has fractions to it too. And what I wanted to show you is that, you can use the simple technique that we learned way back in Chapter 3 of just multiplying the whole equation by least common denominator over 1 and turning everything to whole numbers. So the original problem is negative x over 6 plus y over 2 equals 1/2. The second equation is x over 3 minus y over 6 equals negative 3/4. In this denominator, we're going to multiply by 12 over 1. This one we're going to multiply by 12 over 1 as well. When I multiply 12 over 1 times negative x over 6, I get negative 2x. Multiplying by 12 over 1 here, I get 6y. Multiplying by 12 over 1 to 1/2, I get 6. Here, if I take 12 over 1 and multiply, I get 4x. Here, I'm going to get negative 2y. Here, 3 times 12 is 36, divided by 4 is negative 9. Now, this is a system of two equations. So what happens is, by using the elimination method, I can multiply both equations, or one equation or none equation. In this case, I'm going to multiply the top equation by 2, right here, which will give me negative 4x plus 12y equals 12, which is what this is. Now I'm going to add the equation I didn't turn or change to the one I did change. The x's cancel. Gives me 10y equals 3, which gives me y equals 3/10. Now I'm going to take that 3/10 and substitute it in one of the original equations. So I substitute it in for the y there. Times 2 gives me negative 6/10. If I take this negative 9, which is here, and change it to tenths, I get negative 90 over 10. Adding the 6/10 over, I get negative 84 over 10. I'm going to move that 4, so I'm going to multiply both sides by 1/4, which now gives me negative 84 over 40, which or another way to do this is if 84 divided by 4 is 21, so I get negative 21/10. So I get the ordered pair of negative 21/10 for x, 3/10 for y. Just remember, multiple ways to do these particular problems. I could have just as easily multiplied this by 10 by 4 and got 40, and then reduced the fraction 84 over 40 and got 21/10.